Good afternoon once again, dear student. So today the last topic of first unit, that is data transformation and data discretization, will explain Manasri Agarkar. Okay, so everyone has to concentrate on it, and I will ask some questions. You have to give the answer also. Okay. So first of all, everyone should be glad to her. She is starting today's topic, that is Manasri. Everyone has to concentrate on it. Okay, start Manasri.
Good afternoon, all. Our today's topic is data transformation and discretization. So, first, what is data transformation? Data transformation is a function of mapping entire set of values of given attributes to new set of values in such a way that each old value is identified by some new values. Means जो भी न्यू वैल्यू जो भी ओल्ड वैल्यू है उसे हम कोई तो भी न्यू वैल्यू से मैप करते हैं जिससे कि वो वैल्यू ओल्ड वैल्यू न्यू वैल्यू से आइडेंटिफाई होती है data is transformed in such a way that resulting mining process may be more efficient and patterns founded be easier to understand. There are four data transformation strategies, which is smoothing, attribute construction, aggregation, and fourth is normalization. Smoothing works on removing the noise from data. There are various techniques in smoothing, such as binding, regression, and clustering. In attribute construction, new attributes are constructed and they are added from given set of attributes. Third is aggregation, in which aggregation operations are applied to data and it is used for constructing data cube for data analysis at various abstraction levels. The fourth strategy is normalization. It is the process of scaling data to smaller range. We all know the normalization means dividing the data, the big data into smaller range. There are three types of normalization. First is mean max normalization, second z-score normalization, and third normalization by decimal scaling. So first, mean max normalization. In min max normalization, linear transformation is performed on original data and it has some formula to calculate mean max normalization, that is Vi is equals to Vi minus mean A divided by max A minus mean A into new max A minus new mean A plus new mean A. Suppose we consider that the range is given to us from $12,000 to $98,000 and we have to normalize it to 0.0 to 1.0. We have to calculate it for 73,600. So the value here, the value of Vi minus mean A divided by max A is given as 73,600 minus the mean A value is 12,000, which is the minimum range given to us, and 98,000 minus 12,000, where 98,000 is the maximum value and 12,000 is the minimum value. And here 1.0 minus 0 plus new mean value, which is 0. So by calculating this, we get the answer as 0.716. Now, second is z-score normalization. It is calculated by mean and standard deviation. Uh, it is also having some formula, that is Vi is equals to Vi minus A bar upon standard deviation of A. Suppose that the mean and standard deviation of the values for the attributes income are $54,000 and $16,000, and Z score normalization value is given as 73,600 income. For income is transformed to 73,600, that is VI value, minus 54,000 divided by 16,000. By calculating this, we get the answer, that is 1.225. Now, third type of normalization is normalization by decimal scaling. It normalizes by moving the decimal points of value. The number of decimal points moved is depends upon the maximum absolute value of the A. It is having formula as Vi is equals to Vi upon 10 to the power j, where the j is the smallest integer. Suppose we have given a maximum absolute value as of A as 986 and a range from minus 986 to 917. Then to normalize by decimal scaling, we have considered here j as 3. So the value by which we have to divide becomes 10 to the power j means 10 to the power 3. So it will become as 1000. So by calculating that, we get the value as 0.917. The normalization change original data very in very small part. So next, it is discretization. Uh,
Yes,
Data
Manashri.
transformation समझा क्या सबको?
Yes, Manashri, just repeat the whole part that we have started the mathematical term because these are very important part, right? The formula है, इसको एक बार revise करो, then कौन से वैल्यू मतलब कौन से इसकी कौन सी वैल्यू है वो भी एक बार रिपीट करो तो स्टूडेंट को समझ में आएगा ओके सो जस्ट रिकॉल इट
Okay.
वंस अगेन
There are four strategies of data transformation. First is smoothing, second is attribute construction, and third is aggregation. Smoothing means we have to remove a noise from our data, and second is attribute construction, in which some new attributes are constructed and added to the given set of data. Third is aggregation, in which some aggregation operations are performed and the summary is also taken in this. Fourth is normalization. Uh, in normalization, we have to scale the data in a smaller range. There are three types of normalization. First is mean max normalization, second is z-score normalization, and third is normalization by decimal scaling. So first is mean max normalization, in which we have to perform linear transformation on the original data. Means we have to transform the data up to some scale. Suppose we have given a range from $12,000 to $98,000, and we have to normalize it to 0.0 to 1.0. That means the value which we have given to normalize is the new mean and new max value, and the value as dollar 12,000 and dollar 98,000 are the old max mean and max value. So by using this formula as Vi is equals to Vi minus mean A upon mean max minus mean A into new max A minus new mean A plus new mean A, we have to calculate mean max normalization. So here 73,600 minus 12,000 into 98,000 minus 12,000. It is the old mean max value, and in next bracket there is new mean and max value plus new mean A, that is 0. So by calculating that, we get 0.716.
okay Manashri I am quoting one question here So everyone
Yes,
should
ma'am.
know what exactly normalization is. Anybody can give me the answer. So why normalization is required? Yes, because why we are doing this? This is very important concept. Okay, and in case of minimum and max normalization, so for every feature, the minimum value of that feature get transformed into zero, and the maximum value gets transferred into one. That's why the answer will be 0 and 1. Okay, means answer will be should be 0.0 to 1.0. Everyone should clear that concept. That's why minimum mean max normalization we are going to calculate. Everyone clear this. Minimum value is 0 and maximum will be 1. So value will be like this 0 to 1. Okay. So anybody can tell me the what exactly normalization that we have seen in DBMS. क्यों हम लोगों को normalization करना पड़ रहा है? So you should give the answer. क्यों कर रहे हैं हम लोग? Yes,
Ma'am, to reduce data redundancy.
yes, to reduce.
Data redundancy.
Yes, this is the main basic logic behind it. That is, we have to minimize redundancy from the relation or set of relations. Okay, so that we can easily insert, delete the data. Okay, thank you so much. And that's why it requires the normalization forms, that's 3NF, 2NF, isn't it? So we are not going to detail in DBMS part, but we should know why we are doing this normalization. Okay, Manoj, to continue. Good.
Okay, ma'am. Now, second is Z-score normalization, in which we have calculated using mean and standard deviation. Suppose that we have given the income range from $54,000 to $16,000 and Z-score normalization value as $73,600. Then by using a formula, we have to calculate Z-score normalization. Vi here, the value of Vi, which is Z-score normalization value given as 73,600. So 73,600 minus A bar. A bar means here we have to consider the minimum value, which is $54,000. So 73,600 minus 54,000 divided by standard deviation of A means the maximum value, which is 16,000. So by calculating 73,600 minus 54,000 divided by 16,000, we get answer as 1.225. Then next, normalization by decimal scaling. In this, normalization is done by moving some decimal point of values. Here we have formula as Vi is equals to Vi upon 10 to the power j, where j is the smallest integer. Suppose we have given a range from minus 986 to 917, and the maximum absolute value is here is 986, which is the value of A. Then to normalize by decimal scaling, we consider the division factor as 10 to the power j, and here we are considering the value of j as 3. So the division factor becomes 10 to the power 3, that is 1000. So by calculating using this formula, that is Vi is equals to Vi upon 10 to the power j, we get the answer as 0.917. Normalization can change the original data quite a bit. Means it does not change the data in large format, only the small format is changed of the data. Ma'am, can I continue?
Okay, so my question is
I
that, okay, go to the previous slide. So this is a example which was asked in one examination previous examination, final examination, in which that this type of question is asked. So everyone has to concentrate on that. So how will we are going to calculate Z score, transformation, normalization, and all. Okay. So I hope it's not a big issue to clear. There is one formula is given, and we have to put the value on it and calculate. Okay. So formula you should learn. Okay. This is a major part in the topic. Okay. Go ahead.
So next part is discretization. Discretization is a range of continuous attribute at some intervals. Discretization is the process of transforming numeric data by mapping values to interval or concept labels. Means we have some data in a continuous range with some intervals, and the transformation is performed on the numeric data by mapping the values to the interval. Data size is reduced by using discretization, and it can be repeatedly performed on an attribute. Means we can reduce a data size by using discretization, and it is repeatedly performed on an attribute. Here is example of discretization where attribute is price and interval is between $x to $y. Means first it is given that first interval is $0 to $1000. So we have to classify the children's according to this interval. So in which first is from $0 to $200. Second interval is from $200 to $400. Third is from 400 to 600. Next 600 to 800, and last is 800 to 1000. Means here we have a difference of uh, 200 between each interval, and again in that interval uh, we have classified values in the intervals of 100. So there are again some methods for data discretization. First is binding, which is top down split. Means in binding we split from top to down, and it is unsupervised. Unsupervised means unsupervised provides unlabeled data that algorithm tries to make sense by extracting features and patterns. Second method is a histogram analysis, which is also unsupervised method. Third is clustering analysis, which is again unsupervised. Next is decision tree analysis, which is supervised and again top-down split. Supervised means algorithm which is learned on a labeled data set. Means we have to perform some actions on a labeled data set, and in unsupervised the data is unlabeled, and we have to make some sense from extracting some features and patterns from that data. Next method of data discretization is correlation, which is unsupervised and bottom up merge. Means in correlation we have to merge from bottom to top. It is an example of discretization by histogram analysis, unsupervised data.
So here actually one question arises. What exactly discretization means? Anybody knows? What do you think about it? Yes? What is discretization? Means what exactly we are going to do here? Yes, anybody? Audience? Side. So what exactly discrete means? What? Means we are dividing the data, or we are what exactly the process of discretization in data mining? Yes? Nobody? Yes, Manoj, you tell me.
Ma'am, discretization is the process of dividing a data on some interval. Means a fixed
Okay.
interval is taken and we have to divide the data according to that interval.
Okay. Means we have to divide the data on that interval. Means we are this is the process that putting a value into one bucket. Okay. And so that there are a limited number of possible states we are going to store. Okay. Means the bucket themselves are created as order the discrete value. Okay. Means different value we are going to store into one group. Okay. So like this is discretization. And why we are doing this? Because we have to but after transform the data, we have to apply our data mining algorithms, right? Data separation करने के बाद हमें क्या करना है? This is the process of TDD, right? So data transformation हो
Yes.
गया, data discretization हो गया. Then we have to apply our logic of data mining. That is different algorithm. That is supervised learning, unsupervised learning, clustering, classification. Then we gain the knowledge. Okay. So why we are doing this? It should be known to everyone. Okay, fine. Just recall the previous slide, discretization.
Okay, ma'am.
Again, okay, fine. Yes.
Discretization is a range of continuous attribute of some intervals, and it is the process of transforming numeric data by mapping values to interval or concept labels. Then we can reduce the size of data by using discretization, and it can be performed recursively, means repeatedly on an given attribute. Here is an example of discretization where we have given some intervals, that is first is from 0 to $200. We have to arrange the data between 0 to $200 between this given interval. Second is 200 to $400. The data which comes under 200 to $400 is stored in this interval, and like this we have the last interval as 800 to $1000. Next, data discretization methods. There are different methods for data discretization. First is binding, next histogram analysis, clustering analysis, decision tree analysis, and lastly correlation. So binding, histogram analysis, clustering analysis, and decision tree analysis all binding, histogram analysis, and clustering analysis and correlation are unsupervised. Means they are performed on unlabeled data, and we have to make sense by extracting some features and patterns from that data. And decision tree analysis is a supervised data. That means we have to perform algorithms on a labeled data set. Next, it is a hierarchy generation for nominal data. Nominal attributes have finite but large number of distinct values without any order among the values. So first point in it is specification of a partial ordering of attributes explicitly at the schema level by users or experts. Means here some hierarchy is defined by specifying the total ordering. Means when we write address, then we write first the name of a house, then the area, then city, then state, and then country. So in that some order is fixed. So in this way we in this also there is some hierarchy defined for ordering. Then next is specification of a portion of a hierarchy by explicit data grouping. uh, Many a times we have large number of data sets, and it is difficult for us to define entire concept by explicit value. So we can group that data into small portions, and then we can apply algorithms or we can perform operations on that. Then third is specification of a set of attributes but not of their partial ordering. Means suppose if we have to add time dimensions, then there are many years, many months, many weeks. That means we have some hierarchy of that. So according to that, some attributes are added. Thank you, ma'am.
Okay. So I hope everyone clear that is data transformation and discretization method is okay. So I hope everyone clear that point. Anybody having some doubt related to this? Go to the previous slide, Minister.
Yes, ma'am.
Okay, so we have seen data transformation, data discretization. So here we have to focus on what? Yes, this point is very important that we have seen binding method for removing stopwords and noisy data, that is unsupervised. Histogram analysis, that unsupervised, there is label is not given, and the next one is clustering analysis. Again, it is unsupervised. Okay. Then decision tree analysis. It's very important that we have covered how it is supervised, what exactly supervised and unsupervised it. We are going to see in, that is the third unit, classification unit. That is, I guess, fourth number unit. We need to clear the concept of what decision trees. Okay, so decision tree is very very important topic as per classification is concerned. So how we are going to deal with in decision tree? So first of all, we need to focus on what is supervised and unsupervised learning. So unsupervised means there is no class label is given, already data is providing to us, and we have to, yes, just mute from your side. Yes. Manasya, just mute it. Okay.
Yes, ma'am.
Okay. So I hope, okay. So okay, fine. So what exactly clustering and classification is? I hope 2 to 3 minutes are remaining, I guess. So supervised and unsupervised इसका जो difference है वो properly clear होना चाहिए. Unsupervised means what? जो हम लोगों को डेटा को क्या करना पड़ता है, पर्टिकुलर ग्रुप में स्टोर करना पड़ता है. ओके, सो देयर इज नो क्लास लेबल इज गिवन, according to their attributes we are going to form the group or cluster is nothing but unsupervised. And when we are talking about supervised data learning concept, so supervised means there is class label is given. For example, in decision tree we have given some label, a particular data set is providing to us. सो सुपरवाइज लर्निंग में हमें पहले दो चीजें होते हैं, ट्रेनिंग डेटा सेट एंड टारगेट डेटा सेट. सो डिसीजन ट्री बनाने के लिए हमें ट्रेनिंग डेटा सेट दिया जाएगा सिस्टम के लिए, और उसके बाद हमारा टारगेट डेटा सेट रहेगा. वो क्या करेगा, ट्रेनिंग डेटा सेट को मैच करेगा, देन इट विल गिव द रिजल्ट. दिस इज concept is supervised learning. And unsupervised, there is no training data set is given. This is totally, declustering is depending upon the probability. Okay, we have to predict the value and whether it will goes to this group or not. We'll see algorithm of it, so you can clear all the concept. Okay, so again one point is that I'm going to show one my ME project, so topic mining, so that you can clear all the doubts of how exactly it is working. We'll see. Okay, so I hope everyone is clear today's topic. Any doubt? What exactly data transformation, data discretization? It's very very important, dear student. जब आप खुद से क्लियर नहीं करोगे तब तक समझ में नहीं आएगा. Okay, so anybody having some doubt? Yes. Okay, so thank you so much, Manashri. Manashri has explained very well, so everyone should clap for her. So thank you,
Thank you,
Manashri.
ma'am.
Okay, very good. Some of the students is actively participated, some of them not. Okay, so very good explanation, Manashri. So I hope at the time of algorithm we are going to start, we should clear all the practical way. Okay. Okay. So fine, 4 minutes are remaining. So I'm asking some question to another student that everyone should clear that concept. That is what exactly data transformation is, what exactly data discretization, what are the fields we are going to see. Okay, anybody? Anybody having some doubt? Yes. Ask the question, only 4 minutes are remaining. So we both can give the answer. Okay, so I hope everyone clear this. Yes, Nikita,
Yes,
Anand.
ma'am.
Okay. Any doubt? You can ask the question, no
No,
problem.
ma'am.
Okay. Everything is clear, formula is clear.
Yes,
Okay.
ma'am.
Okay. Fine. These are the actually we are going to see the theoretical part. There is formula is given. We are to put the value on it, calculate and finish. Okay. It's not a big deal to clear the concept. Yes, Sarika Patil saying something. Yes, Sarika. Yes, only 3 minutes are remaining. So anybody having some doubt? Yes, Manasri, you share the screen. That is our presentation. So
Okay,
anybody
ma'am.
having some doubt, they can ask the question. No problem. Yes. Yes. Nobody having doubt how it will work, how we are going to deal with. Okay. So anybody having some doubt on it? What exactly data transformation? So we have to map the value into, we are mapping the unstructured data or unwanted data into in particular format. Okay. So anybody having some doubt or not? I'm asking again the question. Only 2 minutes, I guess, remaining. Yes. Fine. So can I declare that our today's first unit is completed? Okay. Then we are next from today onwards we are going to start the second unit. Okay. And the second unit totally depends upon what our data warehouses means your schema and all the concepts. That is theoretical part actually. But this unit also very important as various questions on that unit. Okay. For final examination. So everyone has to concentrate on that point also. So here is any doubt, that is binding method we have seen, regression analysis, then clustering. Okay, fine. So what exactly aggregation is, how we are going to deal with this. Okay, there are some algorithm, there are some formula is given. We have to put the value on it and finish. So that we have seen previously, that is binding method. Binding method we have seen, that is how to calculate by mean, how to calculate by median, then boundaries. Okay, we have seen all these points. Okay, so I hope everyone clear this. Same points I guess in covered in data analysis also. So the both subjects are correlated actually. Okay, fine. So any doubt till now? Okay, fine. Thank you, students. And nobody having doubt. So everything is clear. So this is Sononi saying something. No? Okay, fine. Okay, so no need to repeat.